So we just concluded proving that in a triangle, if you know different side lengths, maybe this is a better, so it's more visual or more concrete. If you know different side lengths, you can figure out which angle is larger. And it's always going to be the larger angle is going to be opposite the larger side. We are moving now to if you know different angle sizes, how can you tell which side is longer? And you probably will be like, well, duh, it should be out the same thing, shouldn't it? I mean, if the larger side's opposite or the larger angle's opposite the larger side, shouldn't it also be true that the larger side's opposite the larger angle? And the answer is yes, I agree. To prove this, though, we're going to use something called an indirect proof because it's a lot easier. And in an indirect proof, we are going to take whatever we are trying to prove, and we're going to assume temporarily that it's false. And by assuming that it's false, if we can logically deduce that the given is also false, then that is using the contrapositive, which is logically equivalent, and we have actually proved the statement. Once again, I'm not going to ask you to do an indirect proof in class for a test, but I want you to be exposed to it. So we have already talked about how do we start every indirect proof. You start every indirect proof by assuming temporarily that the conclusion or what you're trying to prove is false. And so there's my temporary assumption that segment BC is not greater than segment AC or lengthwise. Actually, when we're talking about inequality, there are three things that can happen. A could be greater than B, A could be less than B, or A could be equal to B. I'm just using variables at this point in time. So we actually have, if BC is not greater than AC, then there's actually two cases. Case one, BC equals AC. So we're going to assume that. So if BC equals AC, and I'm going to, you could do this in statements, reasons, or paragraph. I'm going to go paragraph in this because it's, I'd have to do statements and reasons twice. So if that's the case, if BC equals AC, so BC and AC, if these guys that are marked with a 2 and a 1 are actually equal, then it would be true that angle B and angle A would have to be congruent by the isosceles triangle theorem, right? You guys with me? Then angle A, measure of angle A equals measure of angle B by the isosceles triangle theorem. However, that contradicts because the given is that the measure of A is greater than the measure of B. So I'm going to just point that out. This contradicts the given that the measure of angle A is greater than the measure of angle B. It follows that, well, what did we assume? We assumed that BC was equal to AC. So when we assumed that BC was equal to AC and we got a contradiction, we can now conclude that BC must not be equal to AC. So we've checked off case one. Case two, instead of assuming that BC is equal to AC, we could have that BC is less than AC. We're saying that it's not greater than, so it could be equal or it could be less than. However, remember that if BC is less than AC or AC is longer, then angle B, the measure of B, has to be greater than the measure of angle A, right? Because we've already proved using the statement and two-column proof that the larger the larger angles opposite the larger side. So now we should know that if that's the case, then the measure of angle A is going to be less than the measure of angle B, because in a triangle, the larger angle is opposite the larger side. That's what we just got done proving. This also contradicts the given. This also contradicts this. So we write it out. This contradicts the given that the measure of angle A is greater than the measure of angle B. It follows that what we proved here is false, so that BC is not less than AC. We've done case 2. Well, now we've proved that BC is not equal to AC. We've proved that BC is not less than AC. So therefore, and this is a lazy way to write therefore, 3 dots like that. Therefore, BC must be greater than AC. And we're done. So what I want you to get out of this, because once again, you're not going to be given a indirect proof that you have to do. But here's what you should know on a final exam question or a test on this unit. If I give you an indirect proof, you should know the first step. And I'm not going to make you do the entire rest of the proof, but you should hopefully understand the concept. So the first step is always, if I give you something to prove, assume temporarily that it's not true. So in this case, we assume temporarily that BC was not greater than AC. If I was given this second proof down here, and I want to prove that line L is not parallel to line M, I would assume temporarily that line L is parallel to line M. So whatever I'm trying to prove, the first step in every indirect proof is to assume temporarily that what you're trying to prove is not true. And then look for a contradiction of some known fact, or usually a contradiction of the given. Any questions on that? It's a good place to stop the recording as well. Oops. Sorry, the video is going to be a little longer. Let me start.